estimate or approximate the x-intercepts and turning point or points. So, what are the x-intercepts? Looking at this number 1 graph. -1 and 3. And the turning point appears to be at 1, -4, is that right? -4 and 2. Turning point at -1, -3. How are we doing? Everyone see how I'm getting that information?
King?
Yes.
Is it Bailey Harris?
I do.
Please go to office, please.
Okay. It might be because I counted you absent.
That's probably. Oh, you think you got me? Okay.
I don't know. Maybe. Were you on the announcements as not being absent?
I was on video.
Was it in the announcements?
I hope.
If
you know.
If not, you always need to make sure I know. If it's in the announcements, I'll see it. You know, at the bottom. When it says, I would have to look. I can't remember. So if that ever happens, you always have to make sure that the teacher's classes you're skipping, if it's not on here, that you let them know where you were. Otherwise, you will get counted absent. -2, 0, and 2. Turning points. There are 2 of them. -1, 3, and 1, -3. -3, -2, and 1. Am I going too fast? This one we're going to have to really approximate because it's in between. It looks like -2.5, maybe 0.9. And then negative, I don't know, what do you think, 0.2, 0.1? -5. Now, would I give it to you if these numbers were different? Yes. We're looking for an approximation, so those will not be perfect. X-intercepts, -1.9, 0, and 1.9. Oh, nope, sorry. 2.9. Yeah, I can probably turn that into a 2. And the turning points, -2, -4, 0, 0, and 2, -4. 0 and 2, turning point at 1.2 maybe 3, -1.9.
Okay, so it's the
where it turns around, which would be at a maximum or a minimum. Okay, so that was a bell ringer to lead us into some of the stuff we're going to learn today. We're continuing with polynomial information today. We will continue with polynomial information on Thursday and Friday as well. The first thing we need to talk about are zeros and their multiplicity. First of all, what in the world is a zero? What's a zero, first of all? It is. Zeros, x-intercepts, roots, remember, all the same thing. So a zero, what are the zeros of this polynomial, and can you find them without graphing? Positive 3. Why do you think positive 3 is a 0? Hold on. Good, but why? Why is positive 3 a 0? If I put 3 in here, doesn't this make this whole thing 0? 3 minus 3 is 0. 0 times anything is 0. So it makes the y value 0. Now remember yesterday I said there were 3 ways to find zeros. There's using your calculator graphing screen, using your calculator polysmult, or factoring. Well, this one's already factored for me, isn't it? So, of course, I'm not going to choose factoring most of the time on a polynomial that's not a quadratic. But if it's already factored for me, wouldn't it take you longer to type this in the calculator than to pick out those zeros? So I agree. 3 with what else? -2. Good, hold that thought. What else? -4. And 0. However, would you agree you could write this polynomial, no one would ever want to do it, but you could write it as x times x times x minus 3 times x plus 2 times x plus 2 times x plus 2 times x plus 4 times x plus 4. Would you agree that's the same polynomial?
Yes.
So there's a new word we need to introduce, and it's the word multiplicity. It helps us actually find some things from a polynomial. We can learn some things from a polynomial from the multiplicity. The multiplicity is how many times a 0 shows up. So for example, you see the x and the x? Wouldn't x equals 0 be a 0 twice? Now, you never write it down twice, but... So it is said to have a multiplicity of 2. Do you have to write it all the way out to see that? Where could you have seen that from? The exponent. Okay, what is the multiplicity of 3? Good. It has a multiplicity of 1. What about -2? And what about -4? If you will, put this in your calculator and graph it. I want to show you something cool that you can tell from multiplicity. So put that function in y equals for me. Don't forget, I need all my calculators to stay here today and for the rest of this week. And Peyton, at some point this week, maybe tomorrow, if you end up with time today, you can start today. But get all of the calculators ACT ready. Degree mode, function mode. That way if they stop, or if somebody gets it, they're not in polar mode going, what's R and theta? Get that, get them. ACT. All I really want to look at are the zeros of this polynomial. Those are the places where this polynomial hits the x-axis, which it's a little bit hard to see. On the y's, maybe. Does that do it? Still maybe farther out on the y's. It's probably good enough now. I can't see all the turning points, but I can kind of see what this graph is doing. I want to draw your attention to two places on this graph, or one place on this graph first. Notice the -4, is that -4? Yes, and the 0. When I have those x-intercepts, does it cross the x-axis? It just bounces off of it. Some teachers say it just drops down and kisses it, just touches it. It doesn't cross the x-axis. What were the multiplicities on both of those? The 4 and the 0. The -4 and the 0.
2.
They both had a multiplicity of 2. It turns out if you have an even multiplicity, so 2 is an even number, then the graph does not cross at that x-intercept, it just touches it. So you can know that that's coming based on that multiplicity, which is just kind of a cool thing to know without a calculator, to be able to know it's not going to cross, it's just going to touch. If the multiplicity is odd, it crosses. This is beyond what you need to know, but I'll mention it anyway. If the multiplicity is 1, it crosses straight through. If the multiplicity is 3, it crosses kind of like a cubic. Look at -2. You see how at -2 it kind of has a little cubic shape in it? More information than you would ever need to know, but you can kind of see how that's affecting it. So that's interesting to know. Okay, so we're going to take everything we've learned and put it all together. We are going to learn how to find a relative minimum and maximum in the calculator today, so that we can find those values exactly or close.
Can you send James Salee to A3, please?
I can.
Can I take my stuff? I'll probably get you stuff.
We have 15. You scared me there for a minute. I'm done. Yeah, we get out of here at 15. 15 till on days. Do you want tomorrow and Friday will be shorter. Okay, let's get to the next one. So, x-intercepts. Now, sometimes I may need a calculator to answer that question. On this one, do I need a calculator to answer x-intercepts?
No.
Why not? Because a lot of times I will. A lot of times I can't do that without it. It's already factored. So what are the x-intercepts? +3 and -1. What are the multiplicities of each one of those? And I'm going to put those down in the same order. Otherwise, you need to say which one has a multiplicity of what. Okay, any questions about that? How do I find the degree if it's in factored form? How do I do that? What'd you say? That will be the leading coefficient. The degree is the highest power. Pretend to multiply it out. I'm not actually going to multiply it out because it would take me a while. X minus 3 squared and then times x. What's the only term I care about? The highest power, the x's. So if I were to multiply this out, would you agree the highest power would be x squared? And then the highest power here would just be x. And what is x squared times x? X cubed. So the degree is 3. if I were to multiply this out, my leading term would be 1/3 x cubed. I don't need to know anything else. That's all I need to know. Does everyone know how I got that?
You just multiply the different degrees.
Yes. So I'm kind of thinking in my head, if I were to do x minus 3 squared and FOIL that out, what would be the first term in that? And it would be x squared. And then what would be the first term in x minus 1? Well, it would be x. And then I'm going to multiply those two together. But I am very much shortcutting the process because I would rather not multiply all of that out. Because I don't need to know that. The 1/3 is positive, so the leading coefficient is positive. What is the maximum number of turning points if I'm a cubic? Then this is a calculator question, so I'll skip those for now. Then it's asking end behavior questions. Well, if it's a cubic, as I go to the right, what's the function doing? It's a cubic. Positive leading coefficient. Good. Up to the right, down to the left. With the way they asked that question, I'm going to answer it with the same kind of answer. If they say, what am I doing to the right? I'm going to say going up. But then I'm going to answer this one with the same kind of answer. They're asking me this question. They say, as x goes to negative infinity, what's another word for that? To the left. So what's happening as I go to the left? I'm going down. If I want to answer that the same way they asked it, I'm going to say y is going to negative infinity. I will take both of these on the worksheet or on open response, but just make sure that you can answer both of these on multiple choice, that you recognize. Does everyone know what I mean by that? Sometimes they'll ask it where they ask you to say up or down. Sometimes they'll ask it where they say y approaches negative infinity.
You should one more time. I think that would be great.
Yes. So this, if I were to multiply it out, I don't really want to do it, but I'm just, if I did, wouldn't it be x squared plus something and something else? So the highest power in that piece would be x squared. And then the highest power in this piece is x. And then you multiply, which is, and yes, to multiply two things with the same base, you add exponents. And so if this had been x minus 3 to the 5th, it would be x to the 5th, and then x, so it would be x to the 6th. Does that make sense? You sure?
Yeah.
Okay, cool. All right. To answer the other two questions, I have to pick my calculator up. So I've done everything I can do without a calculator. Once I pick my calculator up, should I check this stuff in the calculator? Yes. It would be a great idea. So in my calculator, I'm going to type 1/3 times x minus 3 squared times x plus 1. So if you had made a degree mistake, when you graph it, you'll probably notice the end behavior. I'm going to go back to Zoom 6, and then if I need to move, I will. Does it appear that our zeros look correct? Yeah, it looks like it. We've got one at -1. Is that what we said? And +2? And the +2 has a multiplicity of 2. Do you see the even multiplicity up there on my screen? See how it bounces on that even multiplicity, but it crosses at the -1? The end behavior, did we get the end behavior right?
Yeah.
Yes. So if you're on a test and you've forgotten how to do end behavior and you happen to have a calculator in your hand, which you always do, graph it and see. And then you could probably backtrack and figure out the highest power and stuff if you were having a hard time with that. Okay. The question is, find the maximum or minimum, or both. Relative maximum or relative minimum. Those are the peaks and valleys on the graph. If you go to second trace, you notice that those are buttons in your calculator. So the first thing I'm going to find, I don't know, you want to start with the minimum? We'll do minimum first. I want everyone doing this with me because a lot of people have a hard time with these calculator steps. This is the minimum. Does everyone agree with that right here? So I'm going to go hover over that minimum with my calculator. Right there. And then it says left bound question mark. From the minimum, I'm going to go to the left, and I'm going to push enter. And then what does it ask? Right bound. So I'm going to go to the right of the minimum and push enter again. And then I'm going to push enter one more time. And I get the minimum to be 3. And then this is kind of weird, and I'm glad we see one of these. That's probably why I picked this example. It says 6.932e negative 16. A lot of people will put 6.932 as the answer. Is that correct? What does that e mean? Times 10 to the negative 16th. It's scientific notation, so it's 0.0000000000000, 16 zeros before it starts the number, right? What is it really trying to say that answer is? 3 what? What's the y value? And look at the picture. What does it look like the y value is? 0. So anytime you see that number with the weird E after it, use your brain a little and go, what does this mean? Calculators are estimating, and sometimes they get a little crazy on that estimation and try to be too exact. It's actually 0, so it's 3, 0 is the minimum. Do you agree with that? So if you ever see that, be careful. So I'm going to draw that point if my computer will catch up. 3, 0. I'm also going to go ahead and put the negative 1 down as an x-intercept. So the relative minimum was the 0.30. Okay, now let's go find the relative maximum. I hope you all do this with me. A lot of people have a hard time doing max and mins in their calculator if you've never tried it yourself. Go to second trace, number 5. Nope, I'm lying. Number 4. Maximum. Go hover over the maximum. Get your cursor on the maximum. And then go to the left and push enter. And then go to the right and push enter. And push enter one more time. And I get 0.333 3.160. Those are decimals. But this time I'm okay with those decimals, right? What was the difference in the last one when I said that just means 0? What was the weird thing about that last one? That e to the negative 16. So this is 0.333. So the relative maximum. Come on, computer. 0.333. 3.160. I do want the calculator decimal answers to that, not just a guess. Degree. Yes. Any questions about that one? We are not going to get to do this problem today, so when you come to those in your homework, skip them. I think that's actually the book work. So when you see a table and it says to do something about modeling the data, we'll finish that tomorrow. The 6.3a worksheet, I think you should be able to do all of it. I think. And should I make sure 18, 19, and 20 you can't do? I think 18, 19, and 20. You will have to wait. Yeah, a worksheet you can do all of. Worksheet done by tomorrow. Got 3 good problems. Go ahead and write them down. But know that you may not be able to do them. Unless you remember how to do it. I'm not. Make sure all my calculators and textbooks and everything get put back where they go before you leave.